right, so this is our first actual proof. All right, and what I mean by first actual proof, it's a first actual proof where we need to go ahead and go through all three of these steps. First one, turn any congruency statements into equations using definition of congruent segments. The second one, if any midpoints are given, turn those into equations using definition of midpoint. And last step is if there are 3 points on a line, use segment addition postulate to create more equations. Right? First part of the segment plus second part of the segment equals the whole segment is the equation we can create. And then lastly, we use substitution to get to the proofs. So we're over here, and we start with our given. Okay, AB is congruent with DE, and BC congruent to EF. Okay, so we write that down. Number one, AB congruent to DE, and BC is congruent to EF. And the reason for that is given. Okay, so what's our first step when creating these proofs? Right? Well, I labeled it as step 3, but it's our first step. It's turn any congruency statements into equations using the definition of congruent segments. So I'm going to do that. I'm going to turn these congruency statements into equations. So how do I do that? I take away the line over it. I'm saying measure AB is equal to measure DE, and measure BC is equal to measure EF. Okay, great. Right? So that's 2 is going to be definition of congruent segments. Right? Okay, so now what do? Well, we turned all the givens, all the congruency statements into equations. Step 2 is, are there any midpoints that are given? Is there any midpoints given? No, there is no. If you had a midpoint given, it'd say that, you know, point B is a midpoint or point E is a midpoint. No midpoints are given, so we skip that step. Third step is now we look at the figure and we say, can we turn this into an equation using seg-adpos? Yes, because we have our 3 points on our line, we can create an equation using seg-adpos on this part of the figure. We can also create one on this part of the figure. So we're going to do that. We're going to create more equations. So it's going to be AB plus BC is equal to AC. Next one is DE plus EF is equal to DF. And that's going to be seg-adpos. Right. First part of the segment plus second part of the segment equals the entire segment, and we do that again with our second set of 3 points. Okay, so now that we've created all our equations, right, we turned congruency statements into equations. We look for midpoint, they didn't give us any midpoint. Then we turned the figure into equations using seg-adpos. Now what do? Substitute to get to that proof statement. We need AC equals DF. Okay. How do we get AC equals DF? Well, we got to figure it out, right? We need these two guys to equal each other. We need AC to equal to DF. And the way that we can get this to happen is if they're both equal to the same thing. If this here on this side is the same as this here on this side, then that means AC and DF will both be equal to the same expression, and then we can use substitution to get AC equal to DF. Okay. So in order to get this left side to equal to this left side of the equation, I need this AB to turn into DE. I need this AB to turn into DE. So the only way to be able to do that is if we have an equation that says AB is equal to DE. Do you have that? Yes, we do. It's right here. We have AB equal DE. Okay, so I'm going to go ahead and take that DE right there, and I'm going to put him here in the place of that AB. That's substitution. Right? Since we have them equal to each other, it means anywhere I see AB, I could put DE. So I'm taking this DE and I'm putting them right there. So it's going to be DE now. Step 4. I need that BC to turn into EF. Okay. Now, the only way I can do that is if I have an equation that says BC is equal to EF. Do I have that? Well, look around and you'll find it. It's right there. BC equal EF. What does that mean? That means anywhere I see EF, I could put BC. Anywhere I see BC, I could put EF. That's substitution. So I'm taking that EF and I'm putting him right there instead of the BC. So I say plus EF is equal to AC. Okay, now we're good. Because look, the left side here is equal to the left side over here. Right? So, I'm sorry, let me do 4 is going to be substitution. So we have that DF and AC both equal to the same expression. That's great. Why? Because what does this equals mean? It means anywhere I see this expression, I could put this expression AC. Anywhere I see AC, I could put DE plus EF. Okay. And so what do I want to do here? I want to take this AC and I want to put it right there where I see DE plus EF. Right? I'm taking this AC and I'm putting him right there. And I can do that because I have an equation that says DE plus EF is equal to AC. So instead of that DE plus EF, I'm going to put AC. So that's step 5. AC is equal to DF. That's substitution. All right. That there is something students have a lot of trouble with. There, you guys are fine by taking this DE and putting it in the place of this AB, right? Where it's one term equals one term, right? The substitution there, you're okay with that. But then once you get to 2 terms is equal to 1 term, all of a sudden it does not compute. Right? But what does this equal mean? It means anywhere I see the left side, I can put this right side. And I see this left side. It's right here. Right? So instead of this expression over here, I could put that AC. And I'm doing that and getting this. If you can understand that form of substitution, then you'll be fine. If you don't understand that form of substitution, work on it because you need to know how that works. Okay? So anyhow, now I'm here. I have equation, but I need congruency statement. So my last step 6 is to turn him into a congruency statement. Like so. Right? And our reason for that is def of congruent segments. But I'm just going to put def of congruence here. And def of congruent lets us go from congruency to equation, but it also lets us go from equation back to congruency. Right? Definitions are if and only if. They go back and forth.